Hello. Today's lesson is on dimensional analysis. Dimensional analysis at first is going to seem to you like, why am I doing this? I can do the math so much easier on my own. I have a method that I do it. But we will eventually get more difficult and you'll be like, I don't understand how to do dimensional analysis. So you need to pay attention. You need to make sure you understand how to do dimensional analysis even at the lowest level. So when we get to the tougher problems, it's going to be all right for you. All right, dimensional analysis is basically just a fancy word for converting. So we know how to convert metrics going from the KHD, BDCM. We can do that all day long just by sliding decimals. But we can also do it through dimensional analysis. So I'm going to show you just a couple things with that. Again, you're going to wonder why I'm showing you, but it's still good. So if I have 27 centimeters, and I would like to get it into a unit like, let's go a kilometer. Okay. I'm trying to get it that unit. What I have here is I have 27, and another way of writing 27 is to put it over 1. So basically I have 27 centimeters over 1. Okay, so that's what it's going to look like. So when I set it up, if I'm multiplying it by something, if I'm converting, I can set it up as the top part of basically just a fraction there. Okay. Now, in order to get rid of a piece that you're looking for as part of your problem, the thing that you're converting, I need to do the opposite function. So if this is on top, this is basically I'm multiplying there. I need to divide by that. So if I have centimeter on top, if I want to get rid of it, I would just put it on the bottom. Now, very, very important thing about these little brackets that I put up here is these things in here have to equal each other. Okay? If these things in here equal each other, they're fair game. You can put them in there. If they don't belong together. You have to put them in another bracket. We'll talk about that here after a little bit. So what do I know about centimeters? I know that there's 100 centimeters in 1 meter. Okay, that's a pretty much set thing that we have across all sciences. We know that. Since I was going to kilometer, I erased that. Since I'm going to kilometer, now I have to see if I know anything about from meters to kilometers. Now see how I put meter up on top? Yeah, I don't want meter anymore. So I'm going to put meter on the bottom. I'm going to do the opposite function of what I just did there. So I'm going to put it right there. Alright, now what do I know about meters? Can I go from meter to kilometer? Sure. I know that 1,000 meters equals 1 kilometer. Okay, so I'm at my unit that I want to get to, and this is how I did it. Okay, centimeter over centimeter cancels out. Meter over meter cancels out. And I'm left with 1 unit of kilometer. Okay, now I have to do the math part. And this is where it gets really simple. We're not doing a whole lot. All we're doing is multiplying straight across the top and divided by the bottom. So if I look at this, I have 27, and I'm divided by 1, 2, 3, 4, 5 zeros on that. 5 zeros would make it 100,000. So when I do that, I'm going to take my decimal and move it over how many places? 1, 2, 3, 4, 5. Drop my little eggs in, and I'd have an answer of 0.00027 in my new unit of kilometer. Alright, now that one was easy, and again, it seemed awkward with me using that particular problem. So I'm going to give you one that's a little more difficult that might make a little bit more sense than why we're using this. I'm going to go for density. I'm going to take something that has a density of 2.7 grams per milliliter. Alright? Now, what this is telling me is I have 2.7 grams for every 1 milliliter. Okay, that's the start of my dimensional analysis problem right there. If you leave it like this, it's a little bit difficult to read mathematically or conceptually. When you look at it, you're like, oh, what do I do with the milliliter? Why is this on the top? When the milliliter really is on the bottom. All right, so I want to take this from grams per milliliter into kilograms per meter cubed. Okay, this grams per milliliter actually is probably going to be the unit you're going to use in chemistry. But this is going to be the unit you use next year in physics. So I'm going to show you this one right here and show you how we would get it done. All right, so I always start with the top one. So I have grams on the top. And since we want to do the opposite function, I'm going to put grams on the bottom. All right, things I should know about grams at this point in time. I should know that there are 1,000 grams in 1 kilogram. Okay, just because the prefix of kilo is 1,000. All right, so the grams cancels out, and looky here, my kilogram is already solved for. I'm done. I'm going to stop with the top part of it now. Now I've got to get meters cubed from milliliter. All right, so here's how I do this. I am going to take milliliter, which is on the bottom, and I'm going to put an opposite function, so it's going to go up on top. All right, milli. What does milli mean? Milli means 1,000. The 1,000th. It's a long day. All right, so what I have here is I could change it to liters, but that doesn't do us any good, and I'm going to tell you why. This is in meters. What is meters? Meters is a unit of length. Milliliters is a unit of volume. All right, so length and volume at first glance don't look like they go together, but in reality they do, because milliliters, or volume, is a derived unit. In order to get volume, I need to take length times length times length, or length times width times height, depending on what you're dealing with there, and we get our volume. All right, so I can get there, but I first need to know what the milliliter is derived from. Okay, and I'm going to tell you that 1 milliliter equals 1 cubic centimeter. Okay, so if I know that that fits right there, 1 milliliter is 1 cubic centimeter. Since these things equal each other, I put them in the conversion. All right, so now a milliliter's gone, and I have centimeters cubed on the bottom. Now, is a centimeter cubed the same thing as a meter? No. So let's get to work. I have centimeter cubed on the bottom. What do I know about centimeters? I know there's 100 centimeters in a meter. At least that's what I hope I know. But what do I know about centimeters cubed? Do I know anything about centimeters cubed and how it's related to a cubic meter? No, we haven't talked about that. So here's what I'm going to do here. I have 1 cubic centimeter. I'm going to put it on top. Or excuse me, I'm going to put the unit on top of centimeter. I haven't put anything other than centimeter, because I don't know anything about centimeters cubed, but I do know centimeters. I know 100 centimeters equals 1 meter. Now, if I were to do the math on this, I have 3 on the bottom, 1 on top. So how many can I get rid of? 1. So now that's 2, and I get rid of that centimeter. So now I have a unit of a centimeter squared times meter. Not good. So let's do this again. 100 centimeters and 1 meter. So now I have done this again. The square is gone, and the centimeter is gone. But I still have 1 centimeter left, so let's get rid of it. 100 centimeters and 1 meter. I am going to do the math there, cross this guy out, and I'm left with meter, 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 which means I have a meter cubed on the bottom. Okay, so if you look here, I've got a kilogram on top, I have a meter cubed on the bottom. My units are correct. If my units are correct, I should be able to do the math and be done. So let's do the math. Since this is a really, really easy one as far as the zeros, I'm just going to do the math right here. I'm going to count my zeros. I have 1, 2, 3, 4, 5, 6. So since I have 6 zeros on here, I'm going to take that. I have 2, 7. There we go. I have 2,700,000. And then I need to divide it by the 1,000 on the bottom. Okay, 1,000 has how many zeros? 3. So what do I need to do with 3 of these zeros? I need to cross them out. Now these are all things that you can do on your calculator, really, really easy. You don't need to do it that way. So my answer is 2,700. Okay, I have 2 sig figs, so that's a good answer. And I am at units of kilograms per cubic meter. All right, if you have any questions on how to do dimensional analysis, open up your book to chapter 4. There's tons of stuff on just sample problems. Make sure you're looking at those. Come in and talk to me about it. Have a great evening.